I think we got this. I think we're gonna crush it. Okay. I think we're gonna crush this. All right. Let's see. What is part 2? All right. So let's read part 2, people. Are you ready? Maybe I can do some more cultural appropriation. Wouldn't that be exciting if I did cultural appropriation? Just as you're about to report your findings to the elf, one of you realizes. Wait, what? One of you? Isn't it just you? Aren't you on a solo mission here? One of you realizes, what? Aren't you like a solo mission, you or the elf? I don't know about that. Realizes that the rules, I mean, it feels like this feels fishy. Not even sure who we're talking about anymore. Realize that the rules have actually been printed on the back of every card this whole time. There's no such thing as points. Instead, scratch cards only cause you to win more scratch cards equal to the number of winning numbers you have. Specifically, you win copies of every scratch card below the winning card equal to the number of matches. So if the card is 10, we're to have 5 incoming numbers. Okay, hold on. Turn it down. I gotta think. You win copies of the scratch card below the winning card equal to the number of matches. Okay, so if card 10 were to have 5 matching numbers, you would win 1 copy each of cards 11, 12, 13, 14, and 15. What? Copies of scratch cards are scored like normal scratch cards. You have the same card as the card they copied. So if you win a copy of a card 10 and it has 5 matching numbers, it would then win a copy of the same cards that the original card 10 won. This process repeats until none of the copies cause you to win any more cards. I think I can do this. I think I can do this. I think I can do it. This one might not take. This one might be a little bit more tricky. All right. Gosh, this is a crazy one. Okay. Here we go. This time, the above example goes a little bit differently. Card 1, dude. What kind of game is this? What do you even win? You win nothing every time. You realize that? You just play the game over and over again until you've won nothing. How is this good? How is this good? Card 1 has 4 matching numbers, so you win 1 copy each of the next 4 cards, 2, 3, 4, and 5. Your original card has 2, so the matching numbers, you win 1 copy of cards 3 and 4. Your copy of card 2 also wins 1 copy of each cards 3 and 4. Your 4 instances of card 3, the original. So we could definitely use dynamic programming, by the way, in this one and go real fast. I don't think I'm going to be that smart. Okay?
Welcome to Costco.
I'm not going to be that smart. Linux, thank you. I don't think I'm gonna be that smart. I tried that shit, it wasn't worth it. It really shouldn't be that hard. You just have a table of what position, and if you've already calculated the winnings, then that's the new ones you add into it.
Welcome to Costco.
Okay, I'd love to explain to you guys how I'm gonna solve this. But it also kind of gives me more time to think about the speed run. So which one do you want? Do you want me to explain how I'm thinking about it, or would you rather have me just run? Speed run? Okay. Okay,
Welcome to Costco.
We can speed run.
I love you.
I can explain it afterwards. What I was thinking. We'll go with dynamic programming too. How does that sound? Well, not only will we go with dynamic programming, we will also. Jake, Sir, Justin, thank you very much, and BreakBN, thank you very much. I appreciate that. So for those that don't know, YouTube, this is the path compression union find path compression algorithm right here. It's literally this algorithm. For those that don't know, and so this is a dynamic programming algorithm right here. So if you don't know, now you know. Okay, now you know. Yeah, it's just a union find, right? Because you're just trying to find the parents. And so you can do path compression along the way. I won't do path compression, but it's effectively union find is all you're doing. You know what I mean? Does that make sense? Okay. I want to give people at least a little bit of, stop stalling. It's not stalling. All right, anyways. Let's see. Your 14 instances of card 5, the original one, and 13 copies have no matching numbers and no more winning cards. Your 1 instance of card 6, the original, has no matching numbers and with no more card. Once all of the originals and copies have been processed, you end up with 1 instance of card 1, 2 instances of card 2, 4 instances of card 3, 8 instances of card 4, 14 instances of card 5, and 1 instance of card 6 in total. This example pile of scratch cards causes you to ultimately have 30 scratch cards. Okay, okay, is that... Okay, so it's just the sum of scratch cards. Okay, so this shouldn't be too hard. I assume it's the same input. Let's go back to here. And so... Shall we shall? Shall we shall? All right. This one I'm a little bit nervous about. I'm a little bit nervous on this one. I'm a little nervous that I'm going to be able to do this one swiftly. But I think I can do it. There we go. There's 1 minute and 25 seconds. So let's do this fun swiftly. No speed for fancy algorithms. Just keep it an array. I know. I'm gonna be smart. Don't worry. I'm gonna be very, very, very smart on this one. And by very smart, I mean extremely stupid, and I'm going to use a very simple version of of Union Find, I think. I'll use like a breadth first search version of Union Find. Does that make sense? Yeah. All right. Is the prediction done? Are we done? I think it's still running. I can't tell when things are done or not done. A breadth first search Union Find. Yeah, that's all I'm going to be doing. All right, let's go. Should be pretty easy. All right, I don't like this next song. Hold on. It's really intense. It goes... I think, right? Yeah. Okay, I actually kind of like it. Oh. All right, I kind of like it. All right. Mother Nature. Mother Nature. All right, let's go. Reset. Start. Go. We're going to jump down here, 6 down here, and we're going to take this. We're going to go back to input, and then I'm going to go like this. I'm actually going to take all of this, and I'm going to head this thing off, and I'm going to call this cards, right? Bam, 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 bam. And I'm going to have a function called... let's see, get, oh gosh, wrong language. Get points, card, right? Which is going to be a string. It's just going to be a string. Let's go like that, bam. And go X. Is it X? Did I use the word X? All right, X, card. There we go. Really? I can't rename? Are you effing serious? All right. All right, I'm just trying to refactor this bad boy. Okay, give me a second. Let points. All right. I think we got everything we need, so there we go. So we got what we wanted, so let's go like this. Make sure I got the things I want. Contents is not defined. Oh, gosh, I went to the wrong one every single time. Oh, wrong. Oh, cards. Make sure I got the right idea. Numbers for each. Okay, so we don't have the right idea. So cards 0 should be something simple. It should be a string. We go like this. We go splats. Numbers split. Okay, hold on. Whoa. What is this thing? What is this line? What is this line? We got something weird going on here. Dang it. All right, so this is the return statement that I do. Okay. So I'm going to go like this. We can keep out that, and we can go like this, and we can go like this. Just for the easiness. All right, perfect. All right, easy. Get that 8. I think that's right? Yeah. Oh no, but it's the number of counts, right? It's the number of matches, right? All right, cool. So now I'm gonna go like this, index. And I'm gonna go like this. Let's see, a new array points. Let's see, fill at index plus. Let's go like this, index plus 1. Let's go like that and go map xi. Yeah, and go x plus I. There we go. Wait, por qué? And then Maria. What do you mean? Wait, how did I just break that up? What did I just do wrong here? Let's just make sure we got this thing correct, because this is gonna be the basis of the algorithm. Okay. New array points. Yeah, that should be fine, right? Oh. Why isn't that doing that? Why, oh, por qué, Maria? Why isn't new array points? Points is 4. Is that not, am I just completely confused? Is not a function? No one's doing a function. Oh, it's because I'm actually that dumb. Fudging meme. Okay. All right, so that isn't cool. I'm spending way too much time here. This was supposed to be a quick move. What do you mean, Nan? Wait, what do you mean? What? Perfect. Okay, perfect. Okay, I'm stupid. There we go. We got those. Everything's nice. Okay, we're good. I know, I'm so stupid.
Welcome to Costco.
I
love you.
roll, let me go. Okay, so this is good. So now that we got get points, we need to take get points. I'm gonna go like this. I'm gonna go const
Welcome
to
to
process.
Costco.
Hey, thank you very much.
love
I
you.
appreciate that. Okay, I appreciate that. Cards.length. Let's see, fill 0. Yep, there we go. I prefer to use something like that. So those are all the ones that I have to go and process. Those are the ones left. Const scene equals this. And what are they going to be? All right, so we're going to go like this.
Welcome to Costco.
Hey,
I
thank
love
you.
you.
Const count equals this. All right, let's do this. So let's go like this. To process equals length. Dude, just get out of here. I don't need whatever you are. All right, so we're going to go like this. To process is going to be const. Do we want to shift? We don't need to shift. Let's do depth first, people. Let's do depth first. We'll process to process dot pop. Let's just use depth first, okay? It's just easier. All right, const points equals get points. It's really cards, right? So we're gonna get the cards. We're gonna reprocess this line. It doesn't matter, right? So const if scene. Then scene IDX or get points cards index. Yeah, there we go. Scene IDX equals there we go. Fantastic. So now that we've seen these, we're going to do that. And once we've done this bad boy, we're going to take each one of the points and we're going to go points dot for each x. Let's see, equals count. Let's go like this. Yeah, we do want to do that. Okay, fantastic. Beautiful, we have all of those. And so that should keep on running. And then we're gonna want to go like this, to process.push x. Okay, fantastic. And then we're gonna want to go like this, console.log count and count object.keys count. Let's see, reduce ACK. Yep. I hate reduces. I always hate reduces. ACK, let's see, ACK, return ACK plus count X, yeah. All right, so that really should be the whole thing. So I have it as 24. I think I'm off by 1. Dang it, I am off by something really small. 30, dang it, what have I done wrong? What is the one that I did wrong? So I have 1 is 1, 2 is 3,
Welcome to
7,
Costco.
13.
I love
Where's
you.
5? Where is 5? Where's 5? Where's 5? Where's 5? See, 0, yes. Okay, 3, 4, 3, 4. 4, 2 should be 3 and 4. 3 should be 4. Wait, does 4 not win anything? Does 4 not win anything? 3 and 4, 3 and 4. So with 4 copies, let's see. Let's see. Hold on. Card 3, the original one, and 3 copies. You have 2 matching numbers. So you win 4 copies of each card's 4 and 5. Okay. Wait. 3, I have just a single point. Is it not a single point? Is input the same still? Input's the same still, right? Is input the same? Am I crazy? 0 indexing? You think that's a problem? You know, I think you probably are. I think you're probably correct on this one. I don't know why you tell me that though. So typically we do not like any hints. Okay, so now since you hinted me, it kind of ruins the experience. You know what I mean? You know what I mean? Because now, I mean, now look at me. Now I can just kind of do this. You know what I mean? You do deserve the ban, okay? You deserve the ban. I just want you to know that now. Okay? You deserve the ban for such nonsense. 2, 3, and 4, 5. 5 results in nothing. 3 results in nothing. So I get 2, 3, 4, and 5. Okay, so the one problem, I'm still getting the same thing. I'm still getting 3's not processing correctly. Why not? Oh man, this should be so easy. This should be so easy. It really should be let's go 4. Right? So the 4th line or 3 should process. Yeah, see, it's only processing 5. Oh, it's not processing. Oh, it's not counting itself? I didn't count myself? Is it as simple as that? Is it as simple as that? Maybe. I mean, I could do it that way, which would be an easy way to say, hey, these are the ones, and then we count on the 4. Yeah, it makes most sense to count this way. I think it makes more sense to count this way. Let's not count this way. That's kind of crazy. Let's count the different way. Let's go like this. Let's go count equals this. Let's count that way. I think that's our big problem right there, is we're counting on the wrong side of things. There we go. 30. Okay. Easy peasy, pumpkin seedsy. It wasn't off by 1. It wasn't any of that crap. And stop. It wasn't any of that crap, people. Wasn't even off. It wasn't even something as simple as that. I just didn't count the beginning ones. Okay. Day 4. I printed everything like an idiot. Uh-oh. Can I stop printing? Have I hit an infinite loop? Can I stop printing? I mean, it's just stupid printing that. It's just printing that took forever. Printing just took way too long. Anyways, we did do a slightly dynamic programming problem. Now, I could have done path compression along it, but I didn't do path compression. That did not take 2 minutes, my friends. That took, I'll give you 40 seconds. Still sucks for you. That was less than 12. That was easy. That was easy. Iro, thank you very much. And Giddy Up, let's go. And Gen X, thank you very much. And Card Oso, appreciate that. How about this one? For the next one, we'll count runtime. We'll count runtime.
Welcome to Costco.
We'll count runtime. TMCP, thank you very much. I appreciate that. Porque Maria. We'll count runtime, okay?
Welcome to Costco. I love you.
That's pretty easy. And this time I'm not gonna. Day 4 took me 2 hours. Day 4 was pretty straightforward. You just gotta. So, all right. Do you want me to explain to you how I did day 4? All right. So it's pretty. The ideal is pretty simple. So we already had the idea of being able to find out how many winners we had. So I just grabbed that and turned it into like the crappiest possible version of it, right? I didn't care about runtime or performance and anything. I just said, hey, here's all the points that are coming back, right? I add 1 and
Welcome
that's
to
that.
Costco.
So all I did is I
love
took
you.
wherever my index was and I added 1 to it, then mapped over the amount of points and literally just did index plus 1 plus I. Pretty straightforward. So I think that this part, I assume everybody thinks that this part is easy, right? Can we all agree that this thing right here, this section is really easy? Yeah, right? That part's easy. So it's what happened here? How did this one work? Well, the basic idea is that once I've calculated the result of an item, I don't need to recalculate the result again. All I have to do is keep the list of points I already got, right? So once I've calculated the list of points, then I permanently have those list of points. So therefore, I put those list of points in here. Now, what I could have done is I could have put those list of points, and then I could have went depth first and adjusted every parent to point further down the line to find the endpoint, and so that way you do path compression along the way as well. I didn't do that. So that means when I see these points, let's just say that 1 finds 1 copy that gets 2, 2 finds 1 copy that gets 3, 3 finds 1 copy that gets 4, 4 finds 1 copy that gets 5, 5 finds no copies, you get 5. It would have literally started off with 1. I would have popped 1 off. I would have added 1 to count to 1. I would have either grabbed our already cached values or calculate them for the first time. That would have grabbed out those points, so then I'd have an array with just 2 in it. I would have then said, hey, let's set scene to be this. Then I'd go over to each one of those and move it into here. I realize this is such a stupid line. I could have done something much different. I could have just simply done like a points.push ... other way around, to process points, right? Anyways, you get the idea. Pretty straightforward. And then we just add those points that we find to the end of the list, pop the next one. So it's just doing a depth first search. That's all it's doing. Pretty straightforward algorithm. That's all I saw in my head. So I mean, the only part that was really of any sort of true difficulty was this first part, just knowing how to split the array. Like if you're not familiar with basic string processing, you may not have noticed that with the input, that this does not matter. That all you care about is this, and you need to split on that. So that's all I did, right? Is I split that away. Hey, split that, drop the game. We don't need it. Okay, then afterwards, split bar. Okay, good. And then we have 2 arrays, right? We have 2 strings, the winning numbers and the number values. Split on space, filter out any empty spots. Those are like the data that we want to keep. I'm going to convert that to a dictionary for fast lookup, which is, I just really converted it to an object. Nothing hard. Then create all the numbers, split them, parse out the ints, trim everything, and then I just look up that. Every time I find an occurrence, add 1 to the points. That's how many points I get, and I just do this little fancy line right here, which is pretty smart. Right? And this line isn't hard either, right? This line isn't very, very crazy either. So go like this. Let points equals 7. Paste that in. Oh my goodness. Let index equals 69. So now when I execute that, you'll notice it goes 70, 71, 72, 73, 74, 75, 76. There you go. 7. Not too complicated. The dict could have just been an array. It probably would have been faster, honestly, being an array. No, it wouldn't have been, because there's like hundreds of values in there.